Hello team. In this challenge, we look at Factorializer, where we are given a number and we need to get the factorial of that number. Now, just so that you remember, factorials are when we take a number and multiply it by each number building up to that. So for 5, it's 1 times 2 times 3 times 4 times 5, right? Which gives us 120, okay? The easiest way to do this is with a little bit of recursion, okay? So we take that number and we multiply it by factorial, which we absolutely can do, right? That's right there. And we go n minus 1, okay? This isn't going to quite work, so don't hit run just yet, but I want to explore this for just a second so that you understand what's happening, right? Because we're actually going backwards here. So if it was that 5, it would be 5 times 4 times 3 times 2 times 1. Brilliant. But the way that this works is that it's actually doing all of this, and then it's multiplying by the 3, and then it's multiplying by the 4, and finally it's multiplying by the 5. It's actually going backwards, which is kind of weird when you think about recursion, but that's how it goes. It goes as deep as it can, and then once it gets to a place where it stops, it rolls it back up, right? And this works. Where it doesn't work is when n gets to 1, right? 1 minus 1 is 0. We haven't accounted for 0. And if we multiply by 0, well, then everything else is 0. So up here, we need a little bit of an if statement, which is n equal to 0, and we return 1. And this is the magic that breaks us out of the recursion. Otherwise, we just keep going, right? We go deeper and deeper, deeper. We would never actually return anything because we sink into a bit of a black hole, right? But this right here, once it gets to 0, boom, it returns 1 and starts the process of doing all of the math, bringing it back up. And now this works, okay? There is a small thing here though, okay? And this is really important if this ever showed up as like an interview question or if you actually had to do this for professional work. Factorials do not work for negative numbers. We just don't do them for negative numbers, okay? Could you? Maybe, but mathematically speaking, we don't. And so what we need to do is make sure that n, if n is negative, we should return an error state, okay? So this, we won't be able to test this today, but you want this, okay? If n is less than 0, right, then throw new error. Too many r's in there, or the r's are in the wrong place. Thank you very much. Not defined for negatives. Brilliant. Okay. This is still going to work. Not a problem. But it just takes that extra bit. Okay. We have no way of testing that today because they didn't give us any negatives to work with. But this is the full solution. Okay. If it's negative, we throw an error. If it's anything positive, right, including 0, then we return a number. And mathematically speaking, 0, the factorial of 0 is 1. There's whole documents out there if you're curious why. And yeah, today, this is our solution. And in testing, yes, we could have done a loop, but in my tests at least, doing recursion was faster. Okay, it was actually faster than the loop, and a little bit cool for situations like this where we're doing it. Learning how to do recursion is a very useful skill. So if this is your first time, welcome to it, and hopefully it's not too much. It doesn't feel too much like a challenge. Did you find other solutions? There are other solutions out there. I would love to see them. Hit me up in those comments. We'll have that discussion. Otherwise, I'll see you in the next one.